Hello students, in previous lecture of bridge course activity of ninth maths, we have studied about the few concepts which is related with the quadrilateral. Today we are going to study about the properties of square, rhombus, parallelogram, trapezium and kite, and the few more concepts which is related with the circles. Then first of all, see here, all of you have studied about the different types of quadrilaterals. Out of that, first of all, see here, square. Then see here, if the quadrilateral of which four sides are congruent as well as four sides of that quadrilateral are right angle. Four sides are congruent as well as four angles are right angle, that means of 90 degree. Let us consider here, that is P, Q, R, S is a square. Then in which PQ, see here, PQ is equals to QR is equals to SR is equals to PS, as well as angle P is equals to angle Q is equals to angle R is equals to angle S is equals to 90 degree. All four angles are 90 degree. Then see here, diagonals. That means see here, diagonals of that square. Here in this diagram, PR and QS are diagonals of that square. Then see here, the properties of square we have to study here, that is all sides of square are congruent. That means here, if PS is 2.4 centimeter, then here PQ is 2.4 centimeter. QR is also 2.4 centimeter. PS and PQ all are 2.4 centimeter. Then second one property, that is all angles are congruent as well as it is 90 degree. That means all four angles are 90 degree. That is the second property. Then see here, diagonal PR and QS is shown in this figure, that diagonals are also congruent. Diagonals are congruent. That means here, if PR is 3.7 centimeter, then QS is also 3.7 centimeter. As well as see here, one more property, that is those diagonals are perpendicular bisector of each other. That means those diagonals are perpendicular to each other, that is those angles are 90 degree. That is, see here, all four angles are 90 degree. As well as here, if PR and QS intersect in point O, then OP congruent OR as well as OQ congruent OS. Then if here OP is 2 centimeter, if OP is 2 centimeter, then OR it is 2 centimeter, as well as OS and OQ. OS and OQ are also 2 centimeter. Then see here, if the sides of the squares are given, then we can calculate the diagonal of that square. See here in this figure, here square PQRS is given here, of which side is 6 centimeter. Then see here PQ is 6 centimeter, QR is also 6 centimeter. Here PQ is 6 centimeter as well as QR is equals to 6 centimeter, and here PQR is 90 degree. Therefore, in triangle PQR, angle Q is 90 degree. Therefore, by using Pythagoras theorem, we can write PQ square plus QR square is equals to PR square. Then PQ 6 square plus 6 square is equals to PR square. Then see here 6 square 36 plus 36 is equals to PR square. See here we can find out the length of the diagonal PR using the lengths of sides of square. Then here we can write 2 into 36 is equals to PR square. Therefore, taking square root on both sides, PR is equals to 6 root 2 centimeter. Or we can write PR is equals to root 72 centimeter. That is about the all about the properties and examples which are based on, that is quadrilateral, that is square. Then we are going to discuss about the one more quadrilateral, that is rhombus. Second one, that is rhombus. Then see here rhombus, it is a quadrilateral of which all four sides are congruent. Then that quadrilateral is called as rhombus. Then see here, suppose here the quadrilateral which is given here, that is quadrilateral BEST, of which four sides are congruent, then it is a rhombus. Then see here few properties of rhombus. See here all sides are congruent, and one more property, that is see here the opposite sides of rhombus are also congruent. That means if see here the angle EST is 110, then angle EBT is also 110 degree. Then the remaining angles, see here angle E plus angle T is equals to angle here plus angle B plus angle S is equals to 360. Therefore, here angle B is 110 degree as well as angle S 110 degree. Therefore, angle E plus angle T, see here opposite angles are congruent. Then we get here, consider those angles are of x degree. Therefore, x plus 220 is equals to 360. Therefore, here 2x is equals to 360 minus 220, that is 140 degree. Therefore, x is equals to 70 degree. That means here those angles are considered as x degree. Therefore, here angle E is 70 degree as well as angle T is also 70 degree. One more property which is related with the diagonal of that rhombus, that diagonals of rhombus is perpendicular bisector of each other. That means the diagonal BS and diagonal ET, those can bisect to each other. Then see here, and if it bisects at point A, then if the length of ET is 70 centimeter, then AE is 35 centimeter and AT is 35 centimeter. As well as if the length of BS is 24 centimeter, then AB is 12 centimeter and AS is 12 centimeter. Then one of the example here given, that is, see here, one of the diagonal of that rhombus, that is BS, here BS is given 24 centimeter and here ET or TE, that other diagonal, is given 70 centimeter. Then we can find out the side of that rhombus. Then see here, using this property, diagonals are bisector of each other. Therefore, as BS is 24 centimeter, then here AB, that AB or AS is 12 centimeter. As well as here T is 70 centimeter, therefore AE and AT are 35 centimeter. Then see here that AS is 12 centimeter and AT is 35 centimeter, and here that angle TAS 90 degree. Therefore, use in triangle TAS, right angle triangle. Therefore, AT square plus AS square is equals to TS square. TS is a hypotenuse of that right angle triangle. Therefore, AT, that is 12 square, plus AS, which is AT, which is 35 square, plus 12 square is equals to TS square. Then 35 square, then see here 1225 plus 144 TS square. Therefore, here 1369 TS square. Therefore, here TS is equals to, taking square root on both sides, TS is equals to 37 centimeter. That means here the sides of that rhombus is 37. All sides are 37 centimeter. As well as see here the diagonals which can bisect to the opposite angles. That means diagonals are bisector of opposite angles. That means if this angle is here, if angle BES is 70 degree, then that angle, see here, those angles are congruent. That is angle BET, see here, BET, as well as angle SET is equals to angle SET, and which are the congruent. And as BES is 70 degree, therefore it is 35 degree. That is about the few properties of rhombus. As well as we can study about the few properties which is related with the parallelogram. See here, all of you have studied about the quadrilateral parallelogram in previous standard. The name itself indicates that the parallelogram, of which it is a quadrilateral, of which opposite sides are parallel, of which opposite sides are parallel. Then see here the diagram in which parallelogram is given here. That is, quadrilateral, here parallelogram PQRS, which is a parallelogram in which the opposite sides are parallel to each other. That means here in this quadrilateral, PS parallel QR and PQ parallel SR. Then few properties of parallelogram we have to remind here. See here, opposite sides of parallelogram are congruent. Opposite sides are congruent. That means here PQ congruent SR, PQ congruent SR and PS congruent QR. That means if PS is 7 cm, then QR is 7 cm. PQ is 3 cm, then SR is 3 cm. Then see here one more property, that is opposite angles are congruent. That means here angle P congruent angle R and angle Q congruent angle S. Those angles are congruent. And see here the diagonals of parallelogram, that is PR and QS, PR and QS, those diagonals of parallelogram which are bisector of each other. That is, they are bisector of each other. If it intersect at point O, then see here OP congruent OR and OQ congruent OS. Suppose here QS which is given is 14 cm, then OQ is equals to OS, that is 7 cm. These are 7 cm. Then here one more property, that is, see here those diagonals also bisect to the opposite angles. That means, for example, here if angle PQR is 70 degree, if it is 70 degree, then see here angle PQS is equals to angle RQS, which are congruent. Those are congruent, and that is 35 degree. Then see here one more property which is useful to solve the examples of that. If this angle is given here, if angle SRP here given is 45 degree, that angle is 45 degree given here, then find out the angle SPQ, then see here if that angle SRP is 45 degree, then see here this angle, that is, if it is 45 degree, then that angle is also 45 degree, because see here, therefore angle RPQ is also 45 degree, because see here RS parallel PQ and the transversal PR. Therefore these are the alternate angles, and alternate angle theorem, that alternate angles are congruent, and therefore see here the property of parallelogram which is used here, diagonal bisect those angles. Therefore here angle RPS is also 45 degree. It is also 45 degree. Therefore angle QPS, here angle QPS is, that is 45 plus 45, that is 90 degree. That means see here those are the few examples which is based on the properties of that parallelogram, and those properties have to used to solve the examples. You may solve the examples which is based on the properties of different quadrilaterals. Then the fourth one, that is trapezium. Trapezium, it is a quadrilateral of which only one opposite pair of that quadrilateral is congruent. That means here in trapezium, that is x, y, z, w, it is a trapezium in which wz parallel xy, that means parallel sides, only one pair of opposite sides are parallel, and wx and zy are non-parallel. They are not parallel, non-parallel. Then what is trapezium? It is a quadrilateral of which only one opposite pair are parallel, and other opposite pairs are non-parallel. That means, see here one more property which is related with the trapezium, that is, see here there are four pairs of adjacent angles are there. Angle x and angle y are adjacent angle. Angle y and angle z are adjacent angle. Angle z and angle w are adjacent angle, and angle w and angle x are adjacent angles. Out of these four pairs of adjacent angles, only two pairs are supplementary. That means here the sum of those angles, adjacent angles, are 180, but only two pairs of adjacent angles are supplementary. For example, see here, if here angle x is 70 degree, then angle y is 110 degree. That is the property which is related with the trapezium. Then see here one more type of quadrilateral is there, that is known as kite. That is, you have generally seen and which have been drawn like this. See here the kite, it is a quadrilateral in which there are two pairs of adjacent sides are congruent. See here, if the quadrilateral A, B, C, D is a kite, then here AB congruent BC. If it is 5 cm, then BC is 5 cm, and AD congruent DC. Then if it is 7 cm, then it is a 7 cm. Then see here diagonals of that kite, that is BD and AC are the diagonals of that kite. See here BD perpendicular to the AC, that means diagonals are perpendicular to each other, and here only BD can bisect AC. See here, that means here BD is a bisector of diagonal AC. That means if here length of AC is 14 cm, then here AO is equals to OC is equals to 7 centimeter. Here OA and OC are 7 centimeter. But AC is not the bisector of BD. That is the properties related with the kite. See here, only one pair of opposite angles are congruent. Then see here, angle BAD congruent angle BCD here, but those angles are not congruent. Only one pair of opposite angles of kite are congruent. And as well as, see here, those are the properties which is related with that kite quadrilateral, and you may solve the examples which is based on the properties of those quadrilaterals. Then few concepts which is related with the circle, we will study about that. See here, all of you studied that circle, of which here seen in the figure, that is point O is a center of circle. As well as here the few concept which is related with the circle, that is radius. See here, radius, OD is a radius, OB is also radius, OA is also radius of that circle. As well as diameter of the circle, that is segment AB is a diameter of circle, which is the largest chord of circle. That is, diameter is the largest chord of circle. Here one more chord which is given here, that is chord PQ. As well as segment AB is also chord of that circle. Then see here the few concept which is related with that circle, that is here radius, that is OB is always half of the diameter. That means R is equals to D upon 2, or D is equals to 2R. That means here diameter is always double of the radius of the same circle. As well as the perimeter, that means here C, which is denoted by capital C, perimeter of circle is calculated by the formula 2 pi r. As well as if the area of that circle we have to calculate, then A is equals to pi r square. Then see here, the total measurement of that circle is 360 degree. Total measurement is 360 degree. And see here, AQB, it is a semicircle. See here, it is a semicircle, and the measurement of that semicircle is 180 degree. Then there are few concepts which is related with that. See here, PQ is a chord, and here suppose X is any point on that circle. Then see here, if that is here, and Y is another one point which is given on that circle, then see here, because of that chord PQ, that circle divided into two parts. Then see here, PXQ, here PXQ is a major arc, and whereas PYQ, here PYQ is a minor arc. Then see here, AXB is a minor arc. Then we can measure the measurement of that arc. Measure of arc AXB is the, see here, measure of that arc is the measurement of that central angle. If that central angle is 69 degree, then measure of that arc is, that is 69 degree. Then see here, angle AOB is a central angle. Angle AOB is a central angle. The measurement of central angle is the measure of that arc, minor arc, subtended by that central angle. Then here AYB arc, measure of arc AYB is a that is major arc, and we can calculate the measurement of that major arc by 360 minus measure of minor arc, that is arc AXB. That means here, if that central angle is 70 degree, then AXB is also 70 degree. Measure of that AXB is 70 degree. Then measure of that AYB is 360 minus 70 degree. Therefore, it is 290 degree. That measure of major arc is the 360 minus the measurement of minor arc. Then see here, few properties which is related with the chord. Then see here, in this example, here O is the center of circle, AB is a chord, and here the distance between O to P is a perpendicular distance of that chord from center O. That means the distance of that chord from the center of circle is the perpendicular drawn on that chord. That is perpendicular drawn on that chord from the center of circle is the distance of that chord from center of circle. Then there is few relationship between those concepts. That is, see here, then OP is perpendicular to, here OP is perpendicular to AB, chord AB. Then that OP bisect to that chord. That means OP is a bisector of chord. If perpendicular drawn from the center of circle on the chord, then it is bisects to that chord. Then see here, if OB is a radius which is of 5 cm, OP is a distance of chord from the center, that is 3 cm, then we can find out the length of that chord. Then see here, OB, that is radius, is 5 cm, OP, that is distance of the chord from center, is 3 cm. Then we have to find out AB. Then see here, OP perpendicular AB. Therefore here OPB, angle OPB is 90 degree. Therefore in triangle OPB is right angle triangle and OB is a hypotenuse. Therefore here OP square plus PB square is equals to OB square. Then see here, OP square plus PB square is equals to OB square. OP, which is given here, 3 square plus PB square we have to find out here, and OB square, that is 5 square. Therefore PB square is equals to 25 minus 3 square, that is 9. Therefore PB square, that is 16. Therefore PB is, that is taking square root on both sides, 4 cm. Here PB is 4 cm as well as AP. PB is equals to AP is equals to 4 cm. Therefore here we get the length of AB. Therefore AB is equals to 4 plus 4, that is 8 cm. That is about the few properties which is related with the circle. Then you may solve the given exercise from day 26 to day 31. From the day 26th July to 1st August. The exercise is given at the last of this video. You should solve that exercise. And on day 33 there is the second unit test. You may do the practice for that unit test by solving the examples from exercise given in this video. Thank you.